att hakten alla fullfest hela dagen. Mjöl från livets grottekvarn. Fullfest hela dagen. Små på stort, det har vi alltid gjort. Så det är fullfest hela dagen. Hakten alla fullfest hela dagen. Mjöl från livets grottekvarn. Fullfest hela dagen. Små på stort, det har vi alltid gjort. Så det magra och tjocka ska ha det bra, ja. Att hakten alla fullfest hela dagen.
Robots information. The first stage, Planetira gearbox. The ratio is 59.2353 and the Planetira 2 is 56.2500. This calculation is from the MATLAB, and the second one is this is the torque 1 10.0566, torque 2 6.1162, torque 3 1.11555, and the ratio 1 is 16.7610, ratio 2 10.1937, the ratio 3 2.5468. I hope you will enjoy the video and enjoy. We use a 3D printer to print all the objects, from designing it in SolidWorks and the calculation of the robot is from the MATLAB, using each joint connected by the Planetira gearbox, the first axis and the second axis, and for the third axis using the pulleys, and calculated it. This is all the parts that we have been printing from a 3D printer, and the time management is long because the sizes of the object are actually big, so the time limit is kinda long, but we have a problem about the filament, but in the process the professor give us a good brand, is the Sun filament. It's a brand, so the printed parts is now very strong and not easy to break, because once one printed object is broken, you have to print it again, and you have to lost the time, and you have to wait until the object has been printed. So the time is kinda slow. The time will slow you down because you printed the broken parts again. And this is the part that you have to get all the printed object from the printer. As you can see the video, I was struggling to get the object out from the printed board. So this is part is kind of hardest part for getting out the printed object and getting out the support filaments from the object that you put the support in. So this is the part that we are starting to assemble each part. This is the group member, Mr. Omar, and we are putting all the parts into a group of arm with the pulleys and the belts and the gripper. This is the part that we are very happy that the Planeteer gearbox works and starting to rotate. This is the first stage Planeteer gearbox, and we are putting it in part and trying it. So as you can see, it's rotation. It rotates kind of well. And now we're putting the ball bearing inside the gearbox. But you can change it by putting a bearing instead of a ball bearing to improve the quality and the speed of the Planeteer gearbox. This part is the second Planeteer gearbox of the robot, and we are trying to put it in place with Mr. Omar and the other members of the group. And after we put it in place, we will put the arm of the robot with the Planeteer gearbox too. And as you can see, the arm and the Planeteer gearbox 2 are put it already, and now we are trying to put the ball bearing inside of it and trying to rotate the arm, and we kind of struggle in this part because of the ball bearing is big and the planet gearbox of the size of the ball bearing is big and the hole of it is kind of small, so we will fix it. And now the robot is starting to rotate. This feels very happy. Now I'll pass it to Mr. Sarit for the code.
First line is include library. I choose servo library servo.net, and next is to divide parameter servo to my servo, and then divide test variable to 55 and divide motor pin, step pin and direction pin, and define limit switch pin. And next is set up the servo that refer to pin 6 and set the servo to 0 degree, and define direction pin and step pin to be output and set it to be low first, and define limit switch to be input. Next is function move to. Function move to has a move to 1, move to 3, move to 2, move to 3 to refer motor to move in clockwise direction. And we have move back 1, move back 2, move back 3 to refer the step motor to move counterclockwise in joy 1, joy 2, joy 3. And function servo and servo underscore. Function servo is to make a servo grab the object, and servo is to make gripper to release the object. And while loop, we set test as previously set test parameter to 55, right? It will go in this state and move infinitely until it hit the limit switch. Which limit switch it hit, it will do the function inside, and it will change the parameter test variable. After that, it will go to next state, and it will move dependent on which limit switch it pressed. If limit switch 5 is pressed, it will move back, something like this, and it will change test variable again. And After that, it will move a little bit and grab the object by servo function, and it will change the test variable and go in next state. It will continue repeat like that. It will do the statement inside, and it will change test variable until the final it will change the test variable back to 55 to loop the program. That's it. Thank you.
So the main problems with our robot is the printing of gearbox due to the different errors between 3D printers. The gearbox body is made of plastic, lack of bearings, difficult to rotate, and all filaments breaking during the printing of large pieces, causing delays. Body is made of plastic and prone to breaking, requiring time to print, replace damaged parts. And the main problem is the robots rotating smoothly owing to a problem with a gear ratio with weight distribution. Overcome this issue, the arm and the gear system should be optimized, and the robot weight distribution and balance, generating rationally smoothness issues. Address this issue to weight distribution and balance must be addressed. So the improvement of this project is use a higher quality material and implement bearings in the gearbox, allow for the smoother rotation, reduce wear and tear of gears, use more precise 3D printers to reduce errors, and regularly check the maintenance of the filaments, optimize the design of the arm and gear system, consider using different type of drive system such as a belt chain drive to improve the smoothness of the rotation, and regularly perform the maintenance to keep all the components good working condition before they become major problems. And the most important thing to improve is using bearings instead of ball bearings, possibly increase a robot's performance and efficiency by decreasing friction and allowing for smoother movement between two elements. So the critical to remember that specific changes that will most beneficially for the robot will be the obstacles that encountering you may find most effective strategies to increase the robot's performance by truly examining this performance and efficiency and identifying the core causes of any difficulties. Do not be embarrassed by your failures. Learn from them and start again. Thank you very much for watching our video from Group A. Thank you.